In the final weeks of 2024, as the world looked toward a new year, a group of telescopes on a quiet Hawaiian mountain captured a flicker of light that shouldn't have been there. It was incredibly faint, almost lost in the background noise of the sky, but its movement revealed something impossible. This object wasn't tied to our sun. It wasn't orbiting anything we knew. It was just passing through. At the Asteroid Terrestrial Impact Last Alert System, or ATLAS, astronomers watched the tiny trace crawl across their screens. At first, it seemed like a glitch, a speck of cosmic dust on the sensor. But the computer knew better. The system had flagged a moving object, one traveling at a speed that defied the gravitational rules of our solar system. They checked everything: the timestamp, the calibration, the weather. But there it was, a faint visitor cutting a straight line through our planetary family, arriving from the vast emptiness of interstellar space. A few phone calls sparked a chain reaction. Observatories across the Pacific awoke. Coordinates were shared, instruments aligned, and before the sun even rose, multiple telescopes confirmed the same astonishing fact. We had another interstellar visitor, the third one ever recorded. It was quickly given a name: 3I Atlas. The third interstellar object discovered by the Atlas Survey. The name sounds clinical, but for the scientists staring at those first readings, it held the weight of an impossible riddle. This had only happened twice before. In 2017, we met Oumuamua, a strange, cigar-shaped object that sped up as it left the sun. 2 years later, Comet 2I Borisov arrived, a more conventional visitor that behaved exactly as we expected. Both were extraordinary, both rewrote our textbooks. And now, a third one was here, fainter, faster, and much, much stranger. Within hours, the data started flooding in. The object's path was hyperbolic, a mathematical curve that basically means one visit only. There was no chance it would be captured by our sun's gravity or ever return. But the numbers told an even more baffling story. Its speed was extreme tens of kilometers per second faster than the escape velocity from any nearby star system. No simple gravitational slingshot could explain how it got moving that fast. The initial reaction among astronomers was pure excitement, quickly followed by disbelief. They'd been waiting for the next interstellar object, but nobody expected one so soon. If these visitors were this common, it meant our galaxy is teeming with drifting debris and perhaps with clues to distant, unknown worlds. Emails flew across continents. Check coordinates. Confirm magnitude. Observatories in Chile, the Canary Islands, and Australia all turned their mirrors to the same spot in the sky. Every single one saw the same faint point, sliding against the backdrop of stars with relentless, unnerving precision. At the Harvard Center for Astrophysics, analysts plugged the early measurements into their models, but the numbers wouldn't line up. The residual's tiny differences between where the object was and where it should be refused to go away. Whatever 3I Atlas was, it wasn't behaving like any asteroid or comet we had ever seen. The mystery was only getting deeper. For the public, it all started with a simple headline: a third interstellar visitor detected. But for the scientific community, it was the beginning of sleepless weeks, frantic scheduling, and intense debate. Every single minute mattered. The object was faint, and it was moving away fast. Every photon they could collect might be the difference between understanding and complete ignorance. Telescopes started measuring its light curve, the way its brightness changed as it tumbled through space. The pattern was irregular. It wasn't the steady rhythm of a sphere, or the periodic flash of something long and thin like Oumuamua. It hinted at a strange, asymmetrical shape, maybe something flat. And as it spun, the changes in brightness were wider than expected, as if sunlight were glinting off polished, metallic facets rather than dusty rock or ice. This is where a sense of unease started to creep in among the researchers. Because the pattern looked engineered. Nobody said it out loud at first. No one wanted a repeat of the Oumuamua controversy, where whispers of alien technology ran wild before the evidence was in. But the data has its own stubborn logic, and soon, private messages between scientists started carrying the same quiet phrase, "This one's different." Different enough that the word alarm started appearing. Not alarm in the sense of fear, but in the way doctors use it as signal for something that defies all normal explanation, and 3i Atlas was one giant alarm. Spectroscopy from Mauna Kea suggested its color was a neutral, slightly bluish tone, unlike the reddish hue of most asteroids. That blue tint meant it was either covered in fresh ice or something highly reflective like polished metal. Neither option fit comfortably. On one conference call, a researcher described it as a cosmic mirror the size of a football field. Another one nervously joked, "Let's just hope it's not aiming back." The joke fell flat. More data poured in, it had no tail. No fuzzy coma of gas, no evidence of outgassing. Nothing that screamed comet, and yet the tilt of its path was weirdly similar to some comets from our own Oort cloud. Was that a coincidence or a clue? What makes 3i Atlas so haunting isn't what we know, it's what we don't. Every new measurement seemed to contradict the last. Every answer just raised a deeper, more profound question. Was it solid or hollow? Natural or designed? A messenger, or just a lonely wanderer? Scientists went back to the archives, reopening the files on Oumuamua. There were similarities, both were small, incredibly fast, and utterly baffling. But Oumuamua had shown a tiny push, a non-gravitational acceleration, possibly from hidden jets of gas. 3i Atlas showed nothing, no jets, no change in velocity. Just a steady, unwavering flight path like an arrow cutting through water. And that steadiness was deeply unsettling. Nature is messy. Objects wobble, surfaces crumble, sunlight pushes things around. This object, however, moved with near-mechanical precision. For a few frantic nights, some even wondered if it could be an old, lost spacecraft. But its trajectory was traced back to the constellation Lyra, far from any path a human probe could have taken. Still, the idea lingered. Could it be a machine? The only way to know for sure was with more data, and time was running out. Every night, 3i Atlas grew dimmer as it raced away from us. Soon, even our most powerful telescopes would lose sight of it. Plans were made for infrared surveys and radar pings, but the object was already too faint, too far away. We were trying to catch a ghost. And yet, the limited data we had painted a paradox. It was an object so small it should have been invisible, yet it was bright enough to be seen. Some argued it had a fresh, icy surface. Others shot back, saying that ice would have created a tail near the sun, a tail we never saw. Back and forth they went, evidence versus inference, equations versus intuition. This was science happening in real time, messy, passionate, and profoundly uncertain. During one tense, late-night call, a researcher from the European Space Agency put it perfectly. He said, if Oumuamua was the what if, then Atlas is the what now. That phrase stuck. Because it was suddenly clear. The universe hadn't just sent us a single anomaly. It had sent us a pattern, 3 interstellar visitors in less than a decade. This means our galaxy is alive with movement. Rocks, comets, fragments, and maybe even artifacts, all drifting silently between the stars. That realization is both thrilling and terrifying. It means our solar system isn't an isolated island. It's a porous border with visitors from unknown origins passing through all the time, completely unnoticed. It's why scientists were both alarmed and intensely curious. Alarmed because each new object shows us how little we know. And curious because each one is a message in a bottle, a message we're desperately trying to translate. By the 20th day, 3i Atlas had faded beyond the reach of most telescopes. Only the largest mirrors in the world kept watch, squeezing the last few photons from its fading trail. Soon, it would vanish completely, leaving behind only datasets, arguments, and speculation. A strange melancholy settled over the community. They had witnessed something unique, perhaps a once-in-a-lifetime event, and all they could do was watch it disappear. For all our technology, we are still just spectators to the grand cosmic theater. We record, we measure, we guess. And sometimes, if we're very, very lucky, we notice when the universe seems to look back. The story of 3i Atlas is the story of that fleeting moment, a spark on a sensor, a whisper of motion across the stars, and the stunning realization that we have been visited. Again, what did we see? What did we miss? And what does it mean for us that objects from other stars keep finding their way to our home? That is the investigation ahead. And it begins right now. Thanks for watching. If you found this journey as fascinating as we did, don't forget to like this video and subscribe for more explorations into the biggest mysteries of our universe.